Okay, in today's video, I am going to go over the voltage rule for parallel resistors. This is the circuit we're going to use. We have three resistors in parallel, R1, R2, and R3. Now this rule applies to any number of resistors in parallel. It doesn't matter whether you have 1, 2, or 3, or 4, or 5, or many more than that. You can apply the same rule to any any parallel resistors. Also, in this video, I'm not going to calculate the voltage drops. I'm just going to go over conceptually how to use the voltage rule for parallel resistors. Now, this is the way it works. We have three resistors and a battery. Voltage of the battery is 9 volts. When the current comes out to the battery, it's going to have 9 volts of energy, 9 volts of electric potential energy, 9 joules per coulomb. I'm not going to go over what coulombs are, I'm not going to go over what joules are, but just suffice to say that each set of electrons, each group of electrons has 9 volts of energy. Now the current is going to come out of the battery, and there's 3 loops. Some of the electrons are going to go through R1, then they'll go back to the battery. Some of the electrons are going to go through R2, and then they'll go back to the battery. And then some of the electrons are going to go through R3, and then they're going to go back to the battery. Okay? When the electrons go through each branch, for example, some of the electrons are going to go through branch 1. They are going to then return to the battery. When they return to the battery, they are going to have no electric potential energy. All of their energy will be used up as they pass through that resistor. Okay, when electrons leave the battery, they have energy. When they come back to the battery, they have no energy. The electrons that go through branch 1 only go through branch 1, so all of their energy must be given to resistor number 1, and that means the voltage drop across resistor number 1, the change in voltage across resistor number 1, is equal to the voltage of the battery. Okay, now the same thing happens for each branch. As we said, some of the electrons are now going to go through branch 2. And when they go through branch 2, they only go through branch 2. When they come back to the battery, they must come back to the battery with no energy. That's just the way it works. Here they go through the battery, go back through to the battery, they have no energy. They must have given all of their energy to resistor number 2. That means the voltage drop across resistor number 2 is also equal to the battery, which is also equal to the voltage drop across number 1. Now, the remaining electrons are going to go through resistor number 3. They only go through resistor number 3. And when they come back to the battery, they must have no energy. Now, since they only went through resistor number 3, they must have given all of their energy to resistor number 3. And that means that the voltage drop across resistor number 3 is also equal to the voltage of the battery, which is also equal to voltage drop across 1 and voltage drop across 2. That is the voltage rule for resistors in parallel. The voltage drop across each of the resistors is equal to the voltage of the battery, even though their resistances are different. Okay, even though the resistances are different, the voltage drops are equal. And of course, the voltage drops would be equal if they had the same resistance, or if they each had the same resistance. So that is the voltage rule for resistors in parallel. The voltage across parallel resistors is equal to the voltage of the battery. When they leave, they have energy. When they return, they have no energy. Okay, so thank you very much for watching. I hope you found that helpful. If you found that helpful, you can give me a thumbs up or a comment in the comment section below, and we will see you in the next video. Thank you very much.